trigonometric form, which means I need an r value and I need a theta value. So to get our r value and theta value, the first thing I'm going to do is I'm going to say, well, you know what? Realistically, this is the point -3, 3 when I put on the imaginary plane. All right. Well, if it's -3, 3, that means our r value is our length, which is going to be the square root of -3 squared plus the square root. Oh, no. Stop. 3 squared. Which is then going to equal the square root of 18, but 9 goes into 18, so that's going to be 3 square root of 2. Oh, no, that didn't help with anything. They're all 3 square roots. All right, so now to get the degree. And the people that get this wrong on the test all the time are the people that are going to be too lazy to draw a picture. Well, it's -3, 3, so it's up here. So if I draw a kind of a fake triangle that works on there, we are going to have -3 and a height of 3. Well, just looking at that, remember what theta is. Theta is this measure right here. Well, I know right now it's somewhere between 90 and 180. Just looking at the picture, there's only one possibility. You didn't have to do any work, really. You could just thought your way through it and got your multiple choice. Well, on the test, it won't be multiple choice, so you better know how to use the beta. So our beta is right here. Well, to solve for beta, we're going to use our tangent of beta equals opposite over adjacent, which is going to be our beta is going to equal our tan inverse of -1. Well, the cool thing about -1 is 1 and -1 always with tangent error of 45 degrees. Well, if I'm in quadrant 2, that must be a -45 degrees. That -45 degrees automatically tells you it's got to either be 180 minus or 360 minus. Well, in this fact, we know it has to be less than 180, so we're going to do our theta equals 180 minus our 45 degrees, which does equal that 135 that we have here. I have my r, I have my theta, so we can go ahead and rewrite this as 3 square root of 2 times the cosine of 130. I guess I can use a parenthesis. All right, 135 degrees plus I times sine of 135 degrees. And that is our final answer, D. D is in darn. I wish I would have picked that one. Yeah.
So for that, can you just look at the unit circle and see that the tangent inverse is like -1?
At 135, yeah?
Yeah, okay.
Uh-huh.
Okay.
You can actually use your unit circle on these because this angle is the same angle you're looking at the unit circle, right? It's the only problem is when it doesn't fall on our unit circle. So if it was way over here and it happened to be on a unit circle, you don't have to do any work. You just go, oh, it's right there, and I have my answer. Yep. Odd. All right, other questions on this one? Questions on the homework? Shane, you figured that one out? Okay. Questions on the homework? Yeah.
It's like that homework, but like for the test.
Uh-huh.
If we like, if it's a radians problem, and we forget to like do radians, actually, never mind.
Good?
Yeah.
Okay. I'm glad I could help. All right, other questions that I don't need to answer? Those are my favorite ones. Okay, if there's no questions for me, then let's go on to today's lesson. Today's lesson is graphing polar equations. Yesterday we learned how to graph points. Today we're going to learn how to graph equations. Well, when I graphed an equation on our rectangular axis, say I had a plot y equals x squared. What you would just do is you plot some points until you got the general shape of it. Then you connect the points and say, well, that's a parabola. All right, and then from then on, you could just plot like 3 points and draw any parabola like that. Similar fashion, we're just going to plot a bunch of points to see what the equation's graph looks like. So in this case, we're graphing r equals 5 times cosine of theta. Remember, When we're dealing with polar, we lose our x's and y's, and we gain r's and thetas. So r takes the place of our y value. So that's why we have r equals our formula. So we have r equals 5 times cosine theta. Well, we're just going to plug in points and see where they lie on our plane. So the first angle I'm going to look for is 0 degrees. Well, that means I need to plug 0 in for my theta. Well, if we plug in our calculator 5 times cosine of 0 degrees, that's just going to equal 5. So our ordered pair, when we're doing polar coordinates, is always r, comma, theta. Our length and our degree. Well, to plot this point, we're going to go out 5 marks, 1, 2, 3, 4, 5, and we're going to go up 0 degrees. I did it. All right, 0 degrees isn't going to move it anywhere. So we're just going to count out 5 and put a point. 1, 2, 3, 4, 5, and put a point. That is my point, 5, comma, 0 degrees. For the next ordered pair, we're looking at 30 degrees. Well, when I plug 30 degrees in for theta, we do 5 times cosine of 30 in our calculator, and that's going to come to about 4.4. That isn't the about symbol. The about symbol should have been 2 squiggly marks. That's actually congruent symbol. It should be 2 squiggly marks would say it's about 4.4, so that's a point 4.4, 30 degrees. Reminder how to graph that. We go out 4.4 units, 1, 2, 3, 4.4, and then we go, it's a positive degree, so we're going to go up, counterclockwise or up. Yep, and we're going to go up 30 degrees, so our point's going to be about here. .4 and 30 degrees is about, maybe about here, I guess.
Can we label them like A and B?
Sure.
Can we just tell you on the
Oh, I don't care. This is yours.
Well, like on a test.
On a test, yeah, you could do A or B or, yep.
Kind of like this and all.
Like where you actually put the points like that. It's a good way to label them. It's just like labeling an X, Y, but as long as you're in the right position, you don't need a label on it at all. All right, as long as you're doing it correctly, you don't need a label. It's kind of like on an XY plane. If I tell you to plot 2, 3, you plot 2, 3, and you don't necessarily put its 0.23 next to it. It's just this is new, and it's in our notes, so I usually put it, it's in the notes. All right, then we do the same thing, and for here we do 3.5 and 45 degrees. I'm not going to do that one. I'm going to skip all the way down to 120 degrees. I'm going to do that one with you guys, so we don't have a whole bunch of wrong graphs. All right, 120 degrees. If we plug 5 times cosine of 120 degrees into our calculator, we should come out with a negative 2.5. So that means this is going to be the point, negative 2.5, 120 degrees. Let's talk about plotting that one because this is the mistake that I've seen classes make. Remember, if I'm plotting negative 2.5, I first do my distance. My distance of negative 2.5 is 1, 2, 2.5. Now I need to go 120 degrees. Since it's a positive 120 degrees, I need to go counterclockwise. So we need to go down in this direction until we go 120 degrees. So once again, we don't need these. These are just for note's sake. We'd be out to, oof, that's a bit too aggressive.
Well, isn't that 300?
Out 2.5 is out here. And then 120 degrees, we're going to go around this way. Well, this right here would be 90 degrees. That would be 90 degrees. Each one of these is 15 degrees. So that would be 90. This would be 105. This would be 120 right here. So this right here would be the point to 120 degrees. Now I don't really need any of this. We really just needed the point. I'm sorry, that'd be negative 2.5. I don't know, I wasn't looking at my thing. That was negative 2.5. 120 degrees. Yes?
I'm so confused why you go like the wrong way even with positive.
I didn't go the wrong way. We always go counterclockwise when it's positive, and we go clockwise when it is negative. So clockwise is this direction,
Wait, no.
or counterclockwise.
Okay.
Counterclockwise is this direction. So if I'm out 2.5 and I go counterclockwise, I still have to go this way.
But if you were like measuring it, what would the 120 degrees be from like?
It'd be from here. It's from our starting point. It's our length. So if you want to look at it as, so see how this is the 120 degree line?
Mm-hmm.
So if I picture this as our 120 degree line, this direction would be a positive 2.5 120. This would be my negative 2.5 120.
But there's no like angle.
There is no angle. It's just a point.
Okay.
We just use the angles to put the points. Yes, there is no angle. There's no, it's not like, I think I know what you mean. It's not like saying, you know, this is 120 degrees. It is our distance and then the degree from that distance, I guess. All right. But see how this is 120 and it is on the 120 degree line? That's a good way to help too. That the positive will go up and the negative will go down in that direction. All right. Your goal is to get the rest of those values, plot it. A hint is you shouldn't be plotting on anything on this side of your thing. If you have points over there, you made a mistake. It'll all be on either that 0.00 or to the right. When you get done with that, you can go ahead and give the next one a shot as well, depending on, because I kind of wait till everyone gets done.
I'm using the system.
Yeah, your system's valid. I don't know.
We're going to have lots of problems with that. We'll fix it.
Okay.
All right, but first I want to go over the circle that you should have created. This is the circle you should have been able to get for that first one, if you plotted everything correctly and got the correct values. If something's off, you may have to use some of your homework time or go online, and this is part of the video. You'll actually hear me saying this is part of the video. Now you hear me saying that I said this part of the video.
This is part of the video.
This is part of the video? Yeah, you're all being videotaped.
What's up, guys?
All right, so if you didn't get the circle, it might be a good chance for you to go back and look at all these values and make sure everything's correct. You have to know how to graph this, all these points. All right, so that is our first circle you should have got. And I do want to point out 5 times cosine theta is a circle with diameter 5. It is a circle with diameter 5. So you wouldn't even need to have graphed this if you knew what that was to begin with. Well, the one below it is also a circle, but since we're using sine, it's a slightly different circle. So if we plot all of these points, you should have came up with something that looked like, it almost looked like if you didn't know it was a circle, you wouldn't know it's a circle. But it should be 2.8 on 45 degrees. 2.8. And then we're up 490. Yeah, it will look like a diamond, but if you know what shape it is,
It's a circle.
it's a circle. It is now a circle. And it is a circle with diameter 4, or a radius of 2. And all, like 6 times sine of theta will be a circle that just goes up to 6 and comes back down. Yeah, Mark.
Is the like center in the equation somewhere?
No. But guess what? Tomorrow we're going to learn how to put it into rectangular form, and then we'll know where the center is.
Or can't you just like draw lines across?
Well, I mean, you actually know where the center is.
Yeah.
I mean, it's not in here, but you know if the diameter is 4, the radius is 2, so it would be the point 290 degrees.
Yeah.
Like here, our diameter is 5, so our radius would be 2.5, so this would be 2.50. So that would be your center of your circle. All right, but rather than plotting everything by a bunch of points, we're going to learn how to use our calculator to graph all this stuff for us. And we'll also look at the limitations of our calculator, and then we'll spend about 5 minutes me walking around fixing everyone's calculators because all of your dimensions are bad and you have a bunch of stat plots still in there that have to shut off. But we'll get around to that in a second. First of all, First and foremost, I have to get my calculator up. My Wabbit. All right, to put it into a mode that lets you graph polar, you first have to put it into polar mode. Crazy. So you're going to go to your mode button right here. So I'm going to click on my mode. There are two things you have to have in here. So this is where you're going to have to put notes to yourself. It needs to be in radians. It has to be in radians. And you have to select this polar right here. Right now, yours is in function mode, which is rectangular. You need to get yours to polar. So make sure yours is in mode. It's got radian. It's got polar. The rest don't really matter. Those are more the stats and stuff. Is everyone in polar and radian mode?
Yes.
Once again, I'd make sure in the notes I say it has to be in radian form. Otherwise, you're going to have the wrong. Now, when I was graphing, say, x squared plus 2, we'd go to our y equals button. We're going to once again go to our y equals button, but we're going to notice it is now r equals. What else I want you to notice, here is our x button. If you click your x button, it will now be theta. You are now in r in theta mode, which is our polar mode. So let's go ahead and graph that first one. That is 3 times sine of 2 theta. So let's go back. 3 times sine of 2 theta. And I'm going to hit graph. And then I'm going to go around.
Theta's a 3.
Hang on a second. I have to. One thing you might have to fix is hit zoom.
Zoom.
And standard, and you should have a butterfly thing.
It's beautiful.
When I hit zoom, it makes me go to Z box.
Exactly. What you want to do?
Oh, zoom in. I see.
Wait, what?
Hang on, I got to fix some settings from the last class that I had.
I made an X. Oh. I think mine's right.
Try zooming in.
Shh. Does anyone say error or something? Yours are both errors? Okay. I would just kind of like 2.5 over this direction, 2.5 up, and just see where they kind of meet. And that would be maybe about here. And this would be my leaf. I'd make another leaf over here, another leaf over here, another leaf over here, and that's as accurate as I want your drawings. All right, so nothing crazy accurate. But now let's start going over the limitations of your calculator. Let us all graph or plot r equals theta. We're going to all plot r equals theta. So I'm going to go back to mine. I'm going to hit y equals, and we already have r equals. Let's just make it theta, and I'm going to hit graph. Does everyone see that little swoosh or that shell or that?
I put it in the wrong way.
Oh, isn't that the thing?
The Nike.
Yeah, it's kind of the thing.
The thing.
The Fibonacci sequence? Yeah, it's kind of that. But let's talk about the limitations of your calculator right now. That is not your entire graph. Your calculator only has so much memory and RAM available to it. So what it does is it limits how many points it's doing and how far it does it. So what I want everyone to do is go ahead and hit that window button. This window button right here. Look at all these thetas. What's happening right now is your calculator is going to plug in 0 and it's going to plot that point. Then if you look at this theta step, it's going to then go to 0.13 about, then plot that point. Then it'll go to 0.26, plot that point, then go to, what was that, look, 5, yeah. It'll just keep going by 0.13 over and over and over and plot that point until it gets to 6.2. That will suffice for most of your graphs. It doesn't suffice for this one. So if you look at this theta max, if we increase that value, say increase it to, I don't know, 10 instead of that 6, and then hit graph, you're going to see it changes your graph a bit. In fact,
I'm gonna change it to 10 mils.
Hang on. Shh. Let me finish. You can play around with the calculator all you want. I'm going to then hit zoom out, hit enter again, and I'm going to increase that number again. So maybe instead of 10, I hit 20, or 22, I guess. If you type in too big of a number, you're going to see it starting getting slower and slower and slower, and you will freeze your calculator. At which point, your hope is that you can hit the on button or the y equals button to stop it and get out of it. I highly suggest you don't just put in huge numbers just to see if you can break your calculator. I'll come around and fix it if you've already done that. Have you already done that? Okay. The original values? Interesting, you should say that. I am now going to hit zoom, and I am going to hit standard, and it will redo all of my stuff, and I'm back to the incorrect answer. So now I'm going to graph this, and then we're going to go over one over limitation. Then you can ask me as many questions as you want about these graphs. So the graph of this is going to look something like that, where it's just going to keep going on forever. All right, it should have an arrow on it. It shouldn't end at the pole, the polar axis. All right, here's one more limitation of your calculator. Look at that graph to the left. It's not this one, but it's similar ones like this. Sometimes your calculator will skip stuff. Your graph on your calculator, so look at my left one. Your graph on your calculator might look something like this, where it looks like it's missing a bunch of information. And that is because your graph isn't graphing everything that's being done. Like I said, it has a preset beginning and ending and step values. So sometimes those points are really far apart and it won't actually connect the points. In that case, if you think you're missing information, you are going to once again go to your window, and you're going to see this start to slow down. See that X step? That's how much it's going up by each increment. You have to make that number smaller so that you can get a line connecting those things. So rather than having 0.13, maybe I'll have 0.05. And you won't be able to see it much on this one, but you're going to see your calculator slow down because it's plotting a bunch more points and taking up a lot more memory. The smaller you make that value, the slower your calculator will graph it, but the more accurate it is in skipping points and stuff. All right, so those are the two limitations of your calculator you might have to overcome. If it looks like it might spiral further, check by extending how far it can go. Rather than being 0 to 6, make it 0 to 10 to see if it actually marks it out further. If it looks like there's gaps in your drawing, make that step value smaller. And when you want to go back, you just hit zoom and you hit standard, and it'll reset everything and you'll go back to your normal speed. All right, any questions on that? All right, is anyone calculators messed up? Okay. It won't let you zoom? Okay, let me come over there.